Hello friends, this is Praveen Chobe, working as Assistant Professor in the Department of Electrical Engineering. I am here to discuss with you about electrical machine design. Especially, I have brought the contents. I'm receiving the queries from you people that the drawing sheet of electrical machine design, especially the transformer drawing sheet, many things out of it are not understood by you, and I'm here to explain, or I would say, to discuss about the electrical machine design drawing sheet, that is especially the design of 25 kVA step down transformer. So you can observe on screen the different cut sections of different views of the transformer are shown. This is basically a three-phase transformer which is shown, and for this three-phase transformer we have developed this drawing in a lab, each part of which we are going to see in detail, and this will be helpful for all of us to answer the questions in oral practical examinations also. Especially if I look at this diagram, I could find the four figures there, out of which the first two figures, those are shown, that is I would say figure number 1 and 2 are the cut sections of three-phase transformer. That is, figure 1 is representing front view and 2 is representing the top view. Figure 3 and 4 more specifically are the figure, those are representing the windings of transformer. That's what I could say about this figure. Now let us see each one of them in detail. We'll go through each one of them in detail so that you will understand what exactly each part of it means and what is exactly the function of each part. So if I focus on the first figure, as I said, I will find there are different parts in this figure, out of which I could say, first of all, we need to understand this is a cut section of transformer. So all the parts of transformer, those are represented on this figure. I have mentioned different parts of transformer depending upon the diagram which is developed here. I could say, if I go through it one by one, each part of transformer, I can find, or I can say, the first part which is representing here, which is very important part, is the frame of transformer. So specifically this part which I'm showing here by encircling is representing the frame of transformer. So a frame of transformer which is represented here, moreover, is made up of mainly the limbs. Those are shown here, say number 1, 2 and 3 limbs are there, and 2 yokes. I could say yoke number 1 and yoke number 2. So 3 limbs and 2 yokes are represented here. The representation is no doubt different. We are going to see what exactly the representation is going to, what exactly the representation is, or I would say, if you go through each part of it, you will understand what is meaning of each part which is represented on the figure. So first of all, I will start with the core part. As I rightly said just now, there are 2 limbs, those are represented. Say this part is representing the yoke 1, yoke 2, and the 3 limbs, those are to be represented there, number 1, 2 and 3. Now representation of each limb is different, which is not normal, or which you could not easily identify. The reason behind that is this is a cut section of transformer which is represented here. So when we are taking a cut section, we could find the limb and yokes depending upon what other parts are present there. So I could say, I will divide this as, or if I look at the first limb, if I concentrate on the first limb, I could say the limb is represented here such that the first part which is represented here is actually, this part is actually representing a limb, this much part. After the limb, there is insulation on both sides. So there is insulation on LHS as well as RHS of this limb. Then there is insulation. After the insulation, there is LV winding. After LV winding, again insulation and HV winding. What I said, you may not be easily identifying it, but if you look at the diagram carefully, you can find it very easy to identify with the representation we have, with the representation which is present here. I could say the representation is showing, first of all, this much part. I could say this is a limb. on both sides of limb there is representation of, say, this is representing, these lines are representing the insulation. After insulation there is LV winding, and then there is HV winding. So this part which you can observe is representing the HV winding on the diagram. This is exactly the HV winding which is shown. Now whenever LV and HV winding part is coming, there may be question, or several times this will be even asked by the external examiner, that why the HV winding which is placed here is placed outside and why it is not placed near the core. So the reason behind that is very well known and known to all of us. We also have discussed this in class. Still I will tell you the reasons why the HV winding is not placed near the core and why it is always placed away from the core. The reasons are very simple. First thing, we know that the tappings, those are provided, are on HV. Tappings are always provided on HV. Then we are going to see it in detail why tappings are provided on HV. Other thing, the insulation requirement, when there is a high voltage winding, the insulation requirement of the winding is high, we could say. When voltage is high, insulation requirement is high. And on the other hand, the number of turns of high voltage winding are more. If number of turns are more and insulation requirement is more, in case of maintenance also, this is very difficult if the winding is placed near the core to maintain that winding. In case of any short circuit which is occurring in the winding, any open circuit which is occurring in the winding, this will become difficult to remove the winding and to maintain it. So in order to avoid these things, we could say the HV winding is placed away from the core. That is specifically I could mention reasons. Reason number one is the HV winding is placed away from the core. The reason number one is the insulation requirement of HV winding is more if it is placed near the core. Hence it has to be provided away from the core. Maintenance is difficult if it is placed near the core. Hence it has to be placed away from the core. And on the other hand, as I rightly said just now, the tapping is provided on HV winding always. So if you are providing the tappings on HV winding, it is better to have this winding outside so that the tapping connections can be made, and in case any fault occurs, that is easy to maintain. So that is how I could say the HV winding is placed away from the core. Now let us come back to the diagram which is shown. If you look at the different representations of this diagram, I can say this part, say number 1, the shapes, identical shapes you could find. This is number 1, then 2, then 3, 4, 5, 6, 7, and 8th one is here. So all these shapes are basically the shapes, those are representing the bolts. Now why these bolts are required, that is again important to be understood by every one of us. The bolts are required to because the reason behind that is, we know that the frame of the transformer is made up of the laminations, different shape of laminations we are using, and while using those laminations, when n number of laminations are used to place them together, the nut bolts are provided. To place the laminations together, we could say the nut bolts are provided. Then if you look at the diagram, you could find the nut bolts as I shown, number 1, 2, 3, 4, 5, 6, 7 and 8. 8 nut bolts are shown here. Number 9th is not shown. The reason behind that, number 9 should be here, but it is not shown as we have represented some different part over there, and we have shown the some structure called tappings here. This structure is representing the tapping part. Hence the nut bolts are not shown here. So if someone asks you in oral examination that why this many number of nut bolts are only shown and why the other nut bolts are not shown, reason is very simple. It is just for representation of tapping, so that we can understand how the tapping part is represented. So I hope this information is useful for you. Then moving further, if you look at the 3 limbs, as I said, limb number 1 which is present here, this is limb 2 and this is limb 3. What these 3 different limbs are representing? These limbs are representing the cut section when we are completely opening the winding, and we are opening. If you look at the transformer winding from outside, you will find the HV winding. First of all, you can see the HV winding. If I cut the HV winding and open it, it will be opened on both sides of the limb. So I could say on both sides I could find the HV winding. Then after opening the HV winding on both sides, I could find LV winding, or before LV winding there will be insulation. If I cut down this insulation and open it, so that could be on both sides of limb. Again you will find the LV winding. I cut down the LV winding, open it on both sides. Again there is insulation, cut down the insulation and open it on both sides. The structure which I said just now is represented on first limb, where there is a limb, after limb, on both sides there is insulation. Some insulation part is shown on both sides of limb. After insulation there is LV winding on both sides. Then after LV winding there is again insulation, and then there is HV winding. Likewise the part is shown here. So I hope this information is helpful for you. Apart from that, then if you look at the second limb here, as shown here, the second limb is representing the cut section, where this structure is representing the shape of LV winding. This is the shape of LV winding. The coils of LV winding are shown here. So LV winding is there. Then after LV winding there is insulation part which is shown here. After insulation part there is HV winding. These are the coils of HV winding. Those are shown. So this structure is representing when I do not cut the LV winding, how the shape looks like. Apart from that, this third shape is showing here, or the third limb which is represented here is just showing the HV winding. This is the HV winding, and these are the number of coils: 1, 2, 3, 4, 5, 6. Likewise, if you count them, that could be exactly similar to number of coils those you have calculated. We might have you might have gone through the design statement. We have calculated the number of coils, and that is exactly represented here. The number of coils are exactly represented here as we have shown in this diagram. So number of coils will be represented. You could count them, and that should be exactly equal to the number of coils those you have calculated. So I hope you understood the three limbs. Limb number 1. The three limbs, those are represented here. This is limb number 1, limb 2, and limb 3. And these two are the yokes. I could say yoke number 1, yoke number 2. If you go into the design part, if you look at the design part of it and the notations, those are represented in design. I can say the height of the yoke, which is represented here, this much shape is representing height of yoke, is represented with HY, height of yoke. So this part is actually representing the height of yoke here. Then like height of yoke, there is one more concept we have introduced, and we have gone through it in the calculation part, in design part, that is height of window. I hope everyone is aware of what window is. So this shape is representing height of window, HW. Apart from that, if I go further, this part is again representing the height of yoke, HY. And the addition of these two, that is, I could say HY. HY is the part which is shown here, HY. Then after HY, the height of window, and another HY. So two yokes, height of two yokes plus height of window, that total becomes the height of frame, and that becomes H, that is capital H, which is one of the main dimensions of transformer. The main dimensions, if you go through the main dimension of transformer, there are two main dimensions. One is called H, other is W, and these are nothing but height and width of transformer frame. The frame which is shown here, all of us are familiar with now what is frame of transformer. I could say this part is actually representing the frame of transformer. So I hope everyone will understand this better now after this discussion. So this part, if you go through, this part will be helpful for you all. Then if you look at the other parts, if I concentrate on the diagram, you could find the diagram is representing not only the frame, but this part inside which the frame is placed is nothing but a transformer tank. Transformer tank is shown here, inside which the frame is fixed. This part, as I rightly said, is representing the frame, where there are two yokes and three limbs. Then to fix the yoke in the transformer tank, we do have used the 4 different shapes. Those you can easily identify on the diagram. This is number 1, 2, and 2 more are present on the other hand, that is number 3 and 4. All these are nothing but the 4 supports. Those are present there to fix the transformer, so that transformer frame should not move here and there inside the tank. Apart from that, 2 more supports you could find over which the transformer assembly is placed. These two are 2 more supports inside the tank, over which instead of directly placing the frame of transformer over the in the tank, they are placed over the supports. Then the other parts, if I look at the other parts of the transformer, this one I have already shown, or I have already told you, these are the tappings, those are provided. And if you look at the connection, those are specially connected to HV winding. So what we are discussing in theory, that the tappings are to be provided on HV side. The reason behind that is very simple. The HV winding has more number of turns. If it has more number of turns, it is better for to provide the tappings on more number of turns or HV side. Reason behind that is very simple, as I rightly said. You will get the flexibility in voltage. When you want to change the tappings, you may get more number of tappings, like we are starting with 1%, 2%, plus or minus 1 or 2% of tappings when we are discussing. When number of turns are more, we could go for 5%, 10% or 15% of tappings. So tappings are provided always on HV side. Apart from that, there is one more advantage. HV winding which is present on outer side, it is better to connect the tapping which is connected here. Like if you can identify this, these are the connections of tapping, those are represented. Then when tappings are provided, we are supposed to provide tapping switches also. Those are represented in this diagram. So the tapping switch is represented here. This part is exactly representing the tapping. As this is a 3-phase transformer, there are 3 windings, hence the tappings are shown here. That is tapping number 1, I could say. This is 2 and this is 3. 3 tappings are shown here. Those could be connected to the 3-phase winding. Then these parts are representing the tapping switches. Tapping switch 1, tapping switch 2 and tapping switch 3. Those could be operated. As we know, tappings are of different type. We have gone through it in detail. You must prepare for what the tapping is and what are the types of tapping. That must be understood by everyone in order to understand the today's discussion. Then the winding, those are present here. These winding are to be connected with some outer circuit. Say in order to provide the input or in order to take the output, we need to connect this winding to some other circuit. So for that purpose, these are the connectors, those are shown. These are the 3 connectors, those are shown, 1, 2 and 3. Several times the students will get confused when there are 3 windings shown. We need to understand that this winding which is shown here is connected to the HV side. See, if you look at this, these are the tappings I said, and the tapping switch, and from there I have taken the connection out. So I could say, if it is connected to the it is connected to the winding where tapping is provided, this is definitely the connections. Connection number 1, 2 and 3, these are definitely the connections of HV winding. These are the connections of HV winding. If these are the connections of HV winding, there is another way to identify them. How to identify them is, I have the transformer design problem. If you go through, I could say this is a transformer which is simply star delta transformer, which we have represented here. If it is star delta transformer, or moreover, if I consider this as step down transformer, if this could be a step down transformer, then I can say for a step down transformer, as the specifications, it is 11,000 volt by 440 volts transformer. So if it is 11,000 volt by 440 volt transformer, I could say this is HV side. Primary winding is HV side. Secondary winding, 440 volt winding is secondary side, which is LV side, right? If this is the winding specification, and this transformer, as I said, is delta star in that case. In that case, this is a delta star transformer. So for delta star transformer, the high voltage winding HV winding is connected in HV winding should be connected in star. HV winding should be connected in delta, and as HV winding is connected in delta, which is represented here, if it is connected in delta, it could have 3 wires output. If it has 3 wires output, then only 3 wires are required here for the connection, and hence only 3 wires are shown. If you are representing these connections for the secondary winding for this case of transformer, or generally I could say if you are representing LV winding is star connected, as we need 4 wire system there. So for a distribution purpose we need 4 wires there, so hence I could say I need to show 4 connections here. These are the connections, those are shown. If these connections are 4 in number, that is for LV winding, and if the connections are 3 in number, I could say this is for HV winding. This is what is understanding out of it. So by looking at the diagram also, I can easily identify if 3 connections are there, this is delta connected winding. If it is delta connected winding, then this must be, if it is delta connected winding, then this must be a HV winding. That's what is understanding out of it. So I hope you will find this useful for the study purpose. Then if I look at the other accessories of transformer, the transformer tank, there is something shown here. One line you can easily identify, this line. This line is actually representing, this line which is shown here is actually representing the level of oil. Actually this has to be filled. The transformer tank has to be filled with oil up to this level. The reason is very simple. Again, the transformer tank is not 100% filled with the oil, but if you measure or if you calculate, this will be filled 70 to 80%. This is 70 to 80% of full length which is available for tank. This is the full length of tank which is available. The tank, if you see, the full length of tank available could be this much. So out of the complete length, I can say it is 70 to 80% filled with the transformer oil. The reason behind that is, again, when the oil gets heated, we require that 10 to 15% or 15 to 20% space which is available here for expansion of oil. As oil gets heated, it will be expanding in nature. Then the other accessories I could concentrate. If you look at this part, this is the same shape you can observe on both sides of tank. This is, say, first shape which is shown here. On the other hand also you will find the same shape. This is nothing but lifting hook. This part is shown here as lifting hook, and this assembly which is shown, this complete assembly which is present on both sides, this assembly is just to lift the transformer from one place to other. Whenever we are lifting the transformer, heavyweight transformer, from one place to other, we need to provide this assembly. So this is for lifting purpose, lifting of transformer. Then the other parts of transformer, if I look at, this is the representation. This is the connection which is going to the breather and conservator. If you observe what is written here neatly, this is the connection which is going to breather and conservator. So breather and conservator connections are present here. Then there is something present here called pressure release valve. This is something called pressure release valve. The purpose is very simple for pressure release valve. Whenever the transformer oil gets heated and the temperature of the oil is beyond certain limit, the pressure is beyond certain limit, that pressure could be released with the help of this pressure release valve. Then the other parts of the transformer assembly I could find easily. This is called a oil drain valve. In case of maintenance of the transformer, whenever we are taking the oil out, then it has to be drained. So it is taken out from this place, this connection. So we'll be calling this as the this part is called drain valve or oil drain valve. Then some other parts of the transformer, if you go through the complete assembly of the transformer, I could say is represented here in cut section front view. If you look at this is a complete diagram of transformer assembly cut section. You can add few more things here, those are not shown. You could add a pressure gauge here. you can represent a pressure gauge here, so that the pressure of the transformer can be identified, how much pressure is there, and that can be displayed if you want. Then the connections of breather and conservator are shown here. If you want, you can add the conservator and breather assembly here, so that you can easily understand, or you can explain it better. The conservator and breather construction and working is well known to all of us. We have gone through it in detail. Apart from that, this was the front view of transformer, cut section front view, which is represented in this diagram. Then when we take the projections from this front view, we could develop a top view of it. Likewise, the projections are taken, you can see, and a top view is developed here in this diagram. This is again something interesting to understand. This top view which is represented here is again something interesting to understand, and it will answer many doubts, or when we go through it, you will understand many things. First of all, the 3-phase winding is there, so 3 limbs are there. We know all the 3 limbs, we could represent them the core number 1, 2 and 3. As we know, for this transformer, when you go through the design part, you will understand there is 2-step core used, whose shape is represented here like this. The shape of the core, if I look at, you can easily identify it, the 2-step core part. Right, you are easily identifying the 2-step core. There are 3 windings, so 3 cores are shown here, core number 1, 2 and 3. Right, so the 2-step core, which is also called cruciform, we know that the word cruciform is similar to the cross-like shape. Hence the word cruciform is directly taken, because this shape is similar to the cross-like shape. I hope you can easily understand what is the meaning of cruciform now. So this is a 2-step core or cruciform core, which is shown here, which is used here. Then we know the circle, which is encircling or which is touching the corners of the core, different corners of the core. We are calling that circle as the circumscribing circle, which is touching the corners of core. That circle is called circumscribing circle. So in this figure, you can easily identify the circumscribing circle is shown. This is a cruciform core. The circle which is just present, which is just touching the corners of the core, we are calling this circle as circumscribing circle. After circumscribing circle, there is the insulation which is present over the core. So if you want to understand this better, if you want to understand this diagram better, I could say the representation is first of all the cruciform core which is shown, then the circumscribing circle which is touching each corner. Actually, it has to touch each corner here. Then after circumscribing circle, there is another circle. This is representing the insulation. You can easily identify the insulation part which is shown here. This much is insulation. After insulation, then if we look at after insulation, the another circle I could draw, and that circle is representing the LV winding. This is the representation of LV winding. So this shape is representing the LV winding. After LV winding, there is again the insulation part. So insulation could be drawn here again, which could not touch actually the winding, but that insulation part is shown, and after that insulation there is HV winding. So if you look at this diagram very carefully, you will observe all the parts present here. There is a cruciform core shown, then there is circumscribing circle, then there is insulation, then LV winding, again insulation, then HV winding. So total, if you look at, I could say the first part, the innermost part in this diagram, the innermost part in the diagram should be core. First is core, which is a cruciform core here. Then there is a circle called circumscribing circle. Then insulation, right? Insulation. After insulation, there is again LV winding. After LV winding, again insulation, and then HV winding. So all those parts are represented over this circle. Then apart from that, if you look at the shape, you can find it interesting once again. What I'm going to tell you is really interesting once again. See, if you look at this shape, these lines are representing something which are not shown here. Actually, they have to be shown like this, because this is the part of same core. This is a core of transformer. For the same transformer, the three, as it is a three-phase transformer, three cores are shown here. And if the representation of one core is like this, like these lines, then these are also the lines, those are present. See, we need to understand, friends, this is a cut section of top view. This is a top view of transformer. If this is a top view of transformer, then we could say, when we are looking from top towards the transformer, when we are looking from top, then after taking the cut section, you can find this part, this part, this part, and this is representation. These lines are the representations of the yoke. This is the representation of yoke. I can show you in this diagram. See, when I'm going to take the cut section of this transformer from here, I have taken a cut section. You need to imagine I have taken a cut from here and I'm looking from top. If I'm looking from top, I could find the core here. The core will be shown here. Then the assembly around it, around the core, all the assembly is shown, and another core is present here, assembly is present here. In between these two structures, what you can identify, what you can look at is the part of yoke. You can identify this, you can check what I said. You will see the lines like this. So that representation is made in this diagram. With the help of this diagram, we could represent. So in practical examination, several times examiner will confuse you with asking such question, that if the lines are shown here, why those lines are not extended towards this. So you need to answer very confidently. Practically, or in fact, this line must be shown up to the third core also, but they are not shown purposely, so that we could understand what parts are represented by each circle of them. So we could easily understand the core, then the after core, the circumscribing circle, then insulation, then LV winding, then again insulation, then HV winding. All these parts are to be understood. So to represent all those parts, we have not extended these lines. Otherwise, one may get confused that what is exactly shown here. That is why representation of this one part is different than the other two parts. Right? I hope you understood. Then when we have designed the tank, we have came across this diagram. If you observe it neatly, we have came across this diagram when we designed the transformer, when we studied it in transformer design. There are some clearances. Those are to be shown in this diagram, and those clearances are again with respect to the core which is shown. The clearances, those could be shown like this. These are the clearances, those must be present. Right? You may be aware of the terms you may have came across. The width-wise clearance, CWW. CWW was considered, CWW is considered as width-wise clearance. Right? Likewise, such terms you have came across, and this diagram is well known to all of us. We all are well familiar with this. If you look at this carefully, some parts are shown here. Like this part is this dimension of the core. The core, once again, you need to understand the core when I am drawing. This is the value which is represented by small a, and this small side is represented with small b. So I hope you can understand this small a and small b, which is shown over here, small a and small b. Then the distance between centers of two cores, or distance between centers of two limbs, moreover, is represented here, which is represented with capital D. So this must be capital D, this is also capital D. I hope you understood this. Then one interesting thing, the question will be again asked several times by the examiner, that what this part is representing. So this part is simply representing the oil fins of transformer. You need to understand, these are the oil fins. When we are taking the cut section and looking from the top, you will easily identify this part as a oil fin. And what is purpose of this oil fins? It will be useful for providing the cooling for the transformer oil. And naturally the oil is filled there, and naturally it is in contact with the air surrounding the tank, and hence cooling will occur there. So these are the oil fins, representation of oil fin, everyone must understand. So I hope this session is useful for you to understand the basics of transformer, and I hope everything related to these two diagrams is cleared. I will request you to post the questions on this video. If you have got any queries related to these two diagrams, you can talk to me, or you can put your queries. I will answer your queries definitely. And as we know, we are suffering with the outbreak due to corona which has occurred there. So instead of wasting your time, I think this video will be useful for all of you, so that you can understand the basics of transformer design. So with this I will stop here. In coming time I will come with a few more videos for you people, so that you will understand the subject, and you can prepare. Instead of wasting your time, you could prepare for the examinations. So I hope you like this video. Please like this video, and please post your queries. Thank you very much.